Welcome, dear students. So we'll continue the discussion on hydraulic pumps. The last session we have discussed about reciprocating pump, and today we are going to see one type of rotary pump. So what is a rotary pump? It is a kind of positive displacement pump. Rotary pump is a type of positive displacement pump. There are two categories of positive displacement pumps. Um, Reciprocating pump and rotary pump. So a certain quantity of fluid will be trapped in a pocket kind of thing will be formed with a vane, screw or gear near the inlet, and that the same volume of the fluid will be displaced to the outlet. So that is the working principle of a rotary pump. So trapping of the liquid in the suction side and forcing that liquid to the discharge side. So inlet, trapping at the inlet and discharging at the outlet, okay, through the side of the casing. So these pumps will not allow the straight movement of the fluid from inlet to outlet. It will block. We will see the schematic diagram of these categories. So they are essentially self-priming because they are capable of removing any air bubbles or air present in the suction line. They can remove it by themselves. The first category of rotary pumps is gear pump. So there are two identical gears rotating against each other in the opposite directions. Two gears will be rotating in the opposite directions. So each gear is supported by a shaft. There will be two separate shafts on which the gears will be mounted with bearings. Small external gear pumps operate at the RPM of 1750 to 3450, and external gear pumps handle viscous and watery type liquids. So you can see the application. So they can handle viscous fluids as well as watery type liquids. Both extremes these gear pumps can handle. So this is the schematic representation. As I mentioned, the rotary pump will not allow the straight movement. This is the inlet and this is the outlet. So the movement of the fluid from inlet to outlet in the straight line is not allowed because this gears will block. So there are two external gears. What do you mean by external gears? The gear teeth are cut on the external outer periphery of the circle. Fine. There are two shafts and the gears are rotating in the opposite direction. This is in the clockwise direction and this is in the anti-clockwise direction. So you can see here the liquid is forced to move in this direction, and a pocket, a certain volume will be formed between the two teeth of the gear and the casing. So a triangular volume here. A volume of the fluid will be trapped here and that will be progressively displaced to the discharge side like this between the gear teeth and the casing. It is pushing or pressurizing the fluid from the inlet side to the outlet side. So that much simple is the working of a gear pump. So these are the different scenarios, I mean the step in the process of discharging the liquid, pressurizing the liquid from inlet to outlet. So this is incoming fluid, this blue color, and the gear is rotating in the opposite directions, and slowly it is getting filled or displaced. So this pocket is displaced to the next, and as the gear rotates, slowly it is getting filled up. The space between the casing and the space between the teeth is getting filled as the gear rotates, and finally it will, when this particular teeth reaches here, what will happen? The fluid will be discharged. Okay, let us see an animation of the same. We can see here the gears are rotating in the opposite directions and the fluid from the inlet to outlet is pressurized and discharged. Fine. So this is the working of a gear pump. Let us see the applications: various fuel oils and lubrication oils. chemical additive and polymer metering industry, chemical mixing industry and blending industry, industrial and mobile hydraulic applications in lifts and all, then acids and caustic construction industry, and low volume transfer or application. In all these kinds of applications, gear pumps are used. So that's all about the first category of rotary pumps, gear pumps. We will discuss about the vane pumps in the next session. Thank you.